Oh my god, it's still recording. Holy shit. Well, take a look at yourself. Ooh, there's my balls. That is incredible. Well, that's a crash.
Greetings, humans. Welcome. The footage you just saw from that lake over in that direction was a crash. A crash of my helicopter. A tricopter specifically. We're going to rebuild it. In this video, we're going to recover the wreckage, we're going to inventory it, and manufacture new parts, configure it, and test fly it. The crash incident happened right above me here, and we landed about here somewhere. Here, check this out. A couple bits of propeller blade. I invite you to follow along on, to be fair, my first attempt at making a proper how-to video. Let's begin. Here we are in the office, and what is the first thing you need to do after a crash? Well, it is to recover your wreckage and see what you got. So let's get into the wreck and see what we have to work with. Okay, our camera survived the run cam, and this guy was running, so we'll just show that now. We also have the FPV camera. I think the failure was actually the ESCs, specifically that one. So we're not going to reuse any of those, but we are going to want to reuse our flight control board, because this is a KK2 Mini. They've discontinued this particular model. They still make the KK2, but they don't make this one for some reason, which is weird because it's better in every meaningful and measurable way. First thing we want to do is unplug some of this stuff. So this is the servo for the camera mount. We'll disconnect that, and since we're not going to reuse these, let's unplug all of the ESCs and the servo just to get it out of the way. Other than having bent pins, this doesn't look too bad. So we're just going to leave that as is, and we're going to reuse that guy. We have this camera mount, which is broken, but still have a working servo. It looks like we just got to reprint this one piece. Get that off of there. I wisely hot glued it together, so. All right, we got a video transmitter. Video transmitter. Let's take a look at these motors. Hear that? That one looks okay. And it doesn't appear to be wobbly, so that one's good. Chop these wires out here, so we're not reusing these ESCs. Here's our broken boom. So obviously we're gonna need a new one of those. Take the snip. 2 motors. Get this stuff out of the way here. Canopy, busted. Servo, and this here screw. Let's keep those, because that is an expensive ass servo. You're gonna want to keep that one. So we got a servo. Awesome. Well, this antenna is not broken. I think we're gonna make a new one anyway. One more motor. Alright, now this ESC, what I suspect is the failure. Now let's cut them all out. This one looks a little wobbly, but the bearings don't seem. Oh, look at that! Look at that! That is the sign of a trash motor. So that needs some more attention. We might not be able to reuse that. Well, that was a fun crash, wasn't it? That looks like a fully reusable boom. Oh, darn. Look at this. I was hoping I could reuse the frame, but it looks like the top is cracked. Shoot! Alright, I guess we're gonna find out how to make a new one of those. I just had to use lock nuts, didn't I? I had to use lock nuts. Let's go! There's a reusable boom. Tricopter frame. Oh, hey, look at that. That is a crushed ass capacitor. So that is number 2. This is number 1. Number 1 is the only BEC on the ESC that powers anything. It's been wrapped in electrical tape for like 9 years. Ooh, it's Eternigy, and it's got a heat sink on it. Wait a minute. What? This doesn't... This one... does not. Oh wait, that is it. That's it. Ah, it's got a heat spreader plate. Okay. Yeah, I like to fly with unreliable bullshit. And this one's obviously Eternigy, because I put the sticker back on. Yeah, I'm pretty sure one of these failed and just killed everything. Am I reusing any of that? No. We're not using that. I know you're screaming at me like right now, like, go get the right tool, dipshit. Hey, I'm padding runtime. It's all about hours view. And, you know, if you don't like it, you can skip it. Because, you know, I put chapters in this bitch. They're down there. Or wherever the hell I'm pointing. If you want to go to the part where I test fly it, you know, that's over there. If you want to go to the part where I wire it, that's like over here. If you want to go to the part where like I 3D print all the nonsense, that's well, there's some of it going on over there. But, you know, one thing at a time. One thing at a time. Well, it might just be that this whole section. So my lips are moving, and then all this stuff is happening at lightning speed, which might look cool, but that won't be informative. Well, this isn't informative, is it? Relax, I'm new at this. Making videos is difficult, but this took a while to plan. This is probably the most difficult video I've made so far. I mean, it's gonna be a bitch to edit, like a real pain in the ass. So, I mean, if you appreciate what I do and you want to see more, you know, it takes me a long time to do these things. And if you like, subscribing is free, and it lets you know, when I make new videos. If you find value in that, you should do that. Also, you know, make a comment, especially if you don't like something I'm doing. Like, let me know. Let me know how I'm screwing this all up, or if my zipper's down or something. You know, whatever. Let me know. Let me know how I'm doing. Alright, let's see. Polycarbonate. I love this material because it's rather ductile. Obviously, I overloaded it and it failed. I think I'm going to reuse the bottom plate because it looks undamaged, and I'll just make a new one on the top. I like the clear ones because, you know, I can see what's going on inside. So, like, when I fold the thing, you know, I can see if there's any wires in the way, and I can be more careful, you know. But folding the thing is probably what made it break in the first place, because I was crushing those ESCs over and over and over again for like 8 or 9 years. Yeah, they're a little trashed. I'm gonna mount them in a different place, just in case you're wondering. Oh, that'll be over here in this chapter, wherever the hell I'm pointing. All right, we got a good... Wow, you know what? I never noticed how badly I cut that thing in the first place. It's all jagged and stuff. But hey, it works. So we gotta make a new one of those. Oh, look at that. That's just falling apart. All right. Recover. And this is, of course, the debris that we're not using, including, most importantly, the ESCs, which most definitely failed. Just some plastic that is cracked and messed up, and one half of the frame, which is fractured. Other than that, we're going to build it all like that, like our power core. Our power core is getting built. That's what the battery sits into and forms the body of all the electronics. Okay. I just want a stick. Just want a fucking stick. Oh, there's dowels. Okay, square dowel, 1/2 inch. This isn't poplar though. What the fuck is this? What is this? Is this pine? What even is this? No, it's a stick. I'm gonna use them. $2.38. Oh my god. Get 3 of those. Well, I don't think it's poplar, but yeah. Sticks. Sticks. We got sticks. Selfie sticks. Inverted marking paint. Inverted marking paint. I don't know. So, this is what we were able to recover. We got 3 motors. We got the servo, television transmitter, a recording camera for the front. We got the FPV camera for transmitting. We got the receiver, the control board, probably fine. It's got to straighten out the pins. We got 1/2 of the frame, undamaged, an antenna bracket. We got the front struts. We got 1 front boom and the aft boom. Leg for the camera mount. And the servo horn for the camera mount. The rest of it we've got to rebuild. We did crash a battery in that crash. I marked that there, and I've plugged it into the charger, balanced it, and it seems to be okay. Just some minor dings on it. I guess we'll see how well that works. And everything else we got to rebuild. So we got our sticks here to replace booms. Have the tail done. So there's the tail. Made myself a new bracket and new antennas. That's what we got for that so far. So we have 1 good boom, which means we have 1 bad boom. So we take our stick and we're going to make ourselves a new one. I'm just going to do this the easy way. And instead of taking measurements off of my design, I'm just going to mark this bitch like that. Jigsaw. Turn that down. Don't need to go that fast. Alright, let's obliterate this here line. Ta-da! We're going to take our nice looking end and line it up with our not so good looking end. And then we're just going to match drill. This is the easiest way to do it. Boom complete. Well, actually, there is another hole in it, but we'll get that when we come to it. Okay, viewers, now let's make some 3D printed parts. I got this beautiful silk filament, very nice and shiny lime green part. First thing we want to do is we want to warm up our machine. Control temperature, nozzle temperature, set it to 90, and swap out the filament. We take our little itty bitty cars.
Here's the model in AutoCAD. First, we're going to type in the command facetrez and set it to 10. This will make the stereolithography files we export the highest resolution possible. Next, type the command stl out, then select a model to export. Pick a folder to save it to, and then name it something sensible. Then just repeat the stl command until you get all the models you need to print. I'm using Creality Print as my slicer, and I'll show my settings in just a moment.
Done. Load that like so. Alright, we're up to temperature here, so we'll just give this thing a yoink. Redeploy this guy. Silk filament. As far as my print info goes, I guess I'll put that up on the screen here so you can read it if you want. I'm going to be doing 4 layers, 4 shell layers, 4 top layers, 4 bottom layers, and I'm using the adaptive cubic infill, and I find that gives me the best interior structure with the least amount of weight. Alright, let's feed this in here. Cool. We're going to get her started. I'm also printing this is a PLA. It's a silk PLA filament, and I'm printing it at 220C, and I'm got a bed temperature of 60C. I'm using the brim type of adhesion. Now we're going to see a time lapse. Whoa, that was a trip. So that's what my nightmares look like. Anyway, my time lapse screwed up because the camera ran out of battery power. So that just happened. Moving on.
All our 3D printed parts are done, and these ones are particularly good looking. That's the rainbow filament, and I happen to get the green to red, so we've got a little bit of a Rasta helmet, and then we've got all our other parts ready, with the exception of the tricopter frame. We only got 1/2, but we do have a piece of polycarbonate. So all we got to do is paste our design on there, cut it out. Now to do this, we could take this one, since it already exists, and trace it out. But I'm going to show you how to do it from the design. So right now we're going to go into AutoCAD and print ourselves a template. So here we are in AutoCAD. What we're going to do is we're going to take our frame design, we're going to move it off to the side, and then we're going to add in some construction lines. These are crosshairs, and that's going to help me use the center punch exactly where I want to put it. Then I'm going to add some lines to make a rectangle around the frame so I can align it to the edge of the piece of polycarbonate that I already have. Then once we're done with that, all we've got to do is print it at the correct scale, which in this case is 25.4. Select the area you want to print, and we're done. Ta-da! So we printed that out in 1:1 scale, and we can paste this onto our piece of polycarbonate, punch the holes so they're exactly right. Let's get started. Since we got a couple flat edges here, we're going to align it to the edges of this so we have to do less work. It's always nice to save time. I think we want to do that edge right there. And these edges are less relevant. And we'll just pick a nice edge of the polycarbonate. This one looks good. Line that up right there. Don't run with scissors, kids. So we want to get these edges lined up. That way we don't have to cut them. It saves us a little bit of cutting. There's no sense in not using as much tape as you want. Preferably clear would be nice, because then you don't have to worry about masking any of the lines. Where'd the OG go? Here we go. So let's just check this against our original. So how about that? It lines up with the OG. Now we're going to use our handy dandy center punch, and we're going to punch the center of the hole. We put the crosshair there so that we could use our center punch and get it directly in the center of the hole, because drill bits are going to follow the dimple. Super! Now before we entertain the idea of drilling all those holes out, let's get our jigsaw, make sure we get that part right first. I find the best way to cut polycarbonate to do it slow. So we're going to set that to 1, and we're going to do it nice and slow. Generally, if you go too fast, you're gonna turn the plastic into some sort of gooey paste, which really sucks. Let's take out this corner first. Let's try not to wreck this table. Oh, Jesus. Well, I set this up for myself really well, didn't I? Damn, curves are a bitch. There's one scallop. I got off. Oh, I got off path. Shit. Make sure your fingers are well away from the blade, kid. Do I really want to cut this down real small? It's just plastic. Fuck it. Alright, we want to tape this back up so we don't totally lose our template. Okay, next. Holy fuck. When you hear the magnet that gets plastic out of your eyeballs, let me know. Can I do this left-handed? Not much more to go. You're gonna have to excuse me for moving you around, viewers. This is not as easy. I didn't plan this as well as I had hoped. Hopefully you learn from my trials and tribulations. Fuck. Ta-da! Ooh, ta-da! We're almost there. Now for the fun part. Shit, where's the OG? Oh, here it is. Okay, let's see. We got 4mm holes, which means we want a 4-ish millimeter drill bit. But first, we're going to use a smaller one. This one mics in at 2.5. So we go from small hole to big hole. That way, if we're off a little bit, we have some meat left there to fix. This technique, I'm going in reverse. I'm using the chisel tip of the drill bit to align to that dimple we made. Once the drill bit is seated, then I flip it into forwards and then send her home. And by all means, keep your digits out of the way of the other end, please. All right, 2.5 millimeters. Now up to 4. Oh, you know what? You know what? We better make sure. Yeah, 4. Provided that you got your holes aligned correctly, the big drill bit should follow the small drill bit. Okay, let's see how we did. American knife. Cut through all our tape. God, why does this always have to be such a pain in the ass to peel? Fuck. Let's go. Oh, baby. All right. Hey, look at that. Now we have a full-ass tricopter. This should be everything we need to make this tricopter. We're just going to go through all of it and put it together. This servo was salvaged from the wreck. We have a new mount for it, which gets glued together. This is a good place to start. Looks like we still got some stuff in here. Yoink. Throw that in the trash. Okay, let's make sure that this fits. That's snug. And I definitely need to chase in this hole with a tap. Where's my fucking tap? Poof, there they are. So here's our 6mm tap. And we're just going to chase this hole down. First gear. That's supposed to be easy. Do 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 do. Don't split. Custom emery board. Hey, look at that. That's done. Good, now I can turn that off. 27 hours, 44 minutes. Holy shit. Okay. That should help with the audio. All right. Don't cut toward yourself. All right, let's fit check that. That looks about right. I might chase that hole. I kind of like that. I kind of like that it threads in a little bit. All right, let's make sure. Before we put it together, we want to make sure this fits. It was a big pain in the ass to get all of the glue off of this, but I succeeded. $9 is a bit expensive for a 9-gram servo. Okay, that looks good. This guy fits like so. That fits like so. Hey, how's the contrast of this shirt, by the way? This probably isn't the best idea. There we go. How's that? The continuity in this video sucks anyway. Yeah, let's roll these up. That looks more cool. We made a new servo horn, so let's make sure that fits first. When you have tiny holes, you need a tiny manual drill. Whoa, come on, Butterfingers. Jesus. Gee, I wonder why I get sick all the time. Oh, of course it's a mess. Oh, Jesus. Labels don't help with these. 107, here we go. That one should do nicely. Let's put all these away before we lose them. I'm really glad I got a giant SD card for that camera. Oh, so many. Come on. Oh, it's magnetic. I don't even have to grab it. Look at that. How about that? Oh, come on. Mosquito clamps. We got this 50 thousandths wire here that was on the old Tricopter, and we need to open up these holes. The 3D printer kind of closes holes that are this small, so we're gonna just drill out the last one. Ta-da! I say that a lot, don't I? Quick fit check here. Let's see. Okay, that part fits. Let's see about... Holy crap. Well, I printed the wrong servo horn. Whoops. All right, let's make sure we get this servo in the right position. Where's ground? Where the hell is ground? Is that it? There we go. Plus minus. Plug this in. There we go. So which way? Which way does it go? It sits in here like that, and we want it to go all the way up this way. Okay. So it sits like this. We want this to be roughly horizontal. That looks pretty good. Or we're gonna go for the last hole here, so let's just drill that out. Well, that was easy. Fit check. Sweet. This guy goes like this. That goes in here. Oh, hey, look, we got more stuff. Pull that out. Could you believe I don't have a 6mm drill bit? I accidentally magnetized all my tools. Yeah, I used to work at a machine shop. I was tapping holes and I needed a left-handed tap to make left-handed threads. The boss was like, well, can't you just tap it from the other direction? Like, dude, no. That's not how that works. Okay, this goes there. Should be in the up position. Let's do a little function check here. Hey, sweet. Our camera mount is functional. Now that that's in the position we want, let's just lock it in with our screw.
Got to do that. All right, time for the CA glue. Cyanoacrylate. This stuff is medium viscosity, which isn't too crazy. All right, now don't get this on your digits. I'm gonna do as much surface area as possible, because why not? Why not go for broke? If you want it to work, just dump it on there. Okay, now we gotta shove this in, work quick. Uh-oh, I'm fucking it up already. Okay. That's where we want it. Cool. And that part we're gonna put there. First, let's get this in place. That'll help us align this whole thing. So make sure I get this all ready to go. Okay. Okay, here we go. Oh yeah, that's locking in now. Hold that. Accelerator. Let's put my cap back on my glue. Okay. Clean up some of this accelerator. Sweet. There's a camera mount. Oh, look at that. Let's assemble. Holy crap. Okay. Let's do a quick check. Ooh, a little crunchy. Let's turn in the screw. Okay, it's a little bindy, but I can fix that later. I don't really need to worry about that right now. Tricopter assemble. Here's the part that our battery goes in, and we're gonna have to start with this because this is where our screws go. Let's get the long ones in there. That's a screw. Six screws in this. Come on. Here's a trick. Haha. Go from the top. There's our 6 screws. Here's our new top plate. Come on. It's like shooting pool with a piece of rope. Aha. We need our antenna block. That goes up here in the front. Come on, fit. Well, that's something I gotta fix. That's why we check these things. Hello, sandpaper. Darn it, viewers, one of our holes doesn't line up. I hate doing this. Not quite. Let's try that again. Sweet. There's our antenna block. The aft boom. Yeah, this way. Cool. Now our front camera mount and a couple of nuts. I'm just going to leave these loose for now. Here's our old aft boom. Stick it right up the butt. No, I still haven't gotten a more sophisticated tool to do this with. Just the pliers. Come on, bitch. Alright, that's tight enough. Now we want our longer screws. And here's our front booms. This is the old left one. Let's see, I marked it.
It goes this way. That's it. Okay. Come on. I'll play this game. Do this the hard way. Don't want to go too tight on there. Here's our new boom for the right hand side. Well, at least the holes line up. So this is supposed to look like that right there. Oh, this is stupid. Is this even possible? Oh, Jesus. Oh my God, there's no way. Hey, look at that. That kind of worked. Here's our camera mount. That should just fit right there. Sweet. Couple of nuts. Oh, Jesus. Where'd it go? Yeah, shortcuts. Ooh, that's too tight. That's too tight. That's why you shouldn't do it with power tools, folks. All right, sweet. Now we need something to stop that. A couple of these. I think that's the right length. Poof. Damn, that's too short too. I'll just use the ones that are too long. I don't think I need them anywhere else. That looks about right. Let's get that on there. A couple of screws. Not trying to tighten these, I'm just trying to take up some slack on this lock nut. It's such a pain in the butt. Let's just snug these up a bit. Cool. Sweet. Hey, we have a tricopter now. A lot of you might be asking, why are you using wood and plastic when carbon fiber is a thing? Well, there's a couple of reasons for that. First being, carbon fiber is kind of expensive. So a carbon fiber stick to make all of these would cost about $60. These 3 pieces of wood total a couple of cents, not even a whole dollar. So there's one reason. Another reason to use wood is that it absorbs vibration and sound very well. So all the vibrations get made by, let's say, used motor. The vibrations get dampened as they travel down the boom so that they don't affect the control board significantly. Also, carbon fiber conducts electricity. It kind of sucks for radios. They actually block radio waves because they can deflect them somewhat and disperse them. As far as using plastic on the frame, again, I'm going to say expense. Also, it's difficult to cut carbon fiber without a laser or a router or something like that. Having just a jigsaw, you know, you can go to Home Depot and get all the things you need. Just a jigsaw and a drill. If that's all you got, this is what you can do. Hey, if you want to spend the money and put the effort into manufacturing your carbon fiber parts, be my guest. Seeing as how I crash all the time, I don't really want to spend all that money over and over again. I mean, I've crashed a lot. I just want to turn this nut. Oh, that's one way to hold a nut. Put a tool there between another part, try to keep it from moving. I did design the space around that so that you could fit a socket over it. I don't have a socket. So this is what we're doing. Okay, we're getting there. Put some struts on. This is gonna take forever to edit. Way too much footage, not enough things to say. Now we can try to put on an aft strut. Cool. Here's the front left. Just slide on. Yeah, the 3D printer doesn't always make the best surfaces. That's more like it. Oh, I did mark it. Look at that. Yeah, I put a... That's where the hole goes. Doo 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 doo. Ooh, that's crunchy sounds. Ooh, Jesus. Hey. How about a tail? It fits. Holy crap. Alright, I don't want to stop now. Let's just keep going. Let's keep going. Ho ho. Hey, hey. Ho ho, ha ha. Alright, that needs some work. Sweet. Check that out. She folds properly. Oh, look, isn't that sweet? Look at this guy. Look at this lady. Tinkerbell, you're looking great. Okay, I gotta work on that a bit. Let's just see. Oh, Jesus. Oh, yeah. You know what? Since we're here, I haven't attached this yet, but this is actually hard to do off of the copter, but I'll screw that in all the way, don't I? Oh my gosh, it folds nice. We got our tail rotor there. Sweet. Next step. Oh yeah, that looks sweet. Let's get the camera mounted. Do the motors. We got our camera mount. Okay, this guy goes right here. Hey, look at that. It's almost like I designed it correctly. Of course it's one that I can't find. Oh, here it is, here it is. Don't lose that, don't lose that. Oh, come on, where's my magnets? FPV camera. That was a cool noise. Hey, sweet. Get in there. Find a hole. I hate little screws. I hate little screws so much. They're lightweight though. All right, camera. So there's our FPV camera. Just for S&Gs, let's check our fit. Okay, there's our front camera module. This is just a recording camera. I don't get to see anything from this. It's got its own battery. I actually mounted in here upside down because when I edit the stuff, I can flip that. That's the way I can actually get to the buttons. Okay, this goes on the front with a 6mm screw. Well, actually it's a bolt because it's connected to a nut. Oh, so simple. And we can tilt that up like the racers do. When I fly, I just leave it flat. This thing isn't particularly fast. Let's get that flat. And just a little tighten. That way I can move it manually. There we go. Okay, so it'll stick. That's what we want. We want it to be sticky and not like super tight. We'll put our screws in. Well, you know what? Let's use some washers. That's extra weight, but who cares? It looks cool. I never have the Allen key I want. I'm just gonna do these by hand. Oh, if I just had the right Allen key, this would be so much easier. That doesn't make any sense. Alright, let's just I might have to come back to this one. Yeah, that's a little janky. We'll have to come back to that. That's actually a 4mm hole. Let's see if we can drill this straight, go high speed. Let's make sure it's 4. Yeah, 4. Let's go from this way now. Oh, I got a nut on there. Hell yeah. Alright, this one should just line up. It does not. Those are bolted in. Sweet. Let's deal with the motor mounts. Now we're getting into the motor mounts. Tail rotor wires go off to one side. I like putting them off to the left. I threaded these holes off camera because, you know, it just takes forever. No one wants to see that BS. 1, 2, 3, 4. Let's mount up the tail. Tail rotor. We want to make sure the servo's centered, so let's get this tester plugged in. Hit the center. That's center. All right, we want to point that straight up, put that in place. This here is a $158 Panduit zip tie tool, and I love this thing. I'm going to set this to maximum tension. All right, here's the magic. So simple. So easy. This servo horn I built does have a spline on it, but it wasn't as reliable as I'd hoped, so I also added a set screw, and that goes here. And that should give us a little bit of insurance to make sure this thing doesn't slip. I don't want this thing to slip. There we go. All right. Oh yeah. That's a tail rotor, baby. Sweet. Let's put that to center, disconnect. Tail rotor, done. Right, now for the boring motors. These need to be aligned toward the boom, so we want the square to line up with the wires here. Oh, hey, that's bent. Okay, well, let's fix that. That's how easy it is. All right, after we get the first one started, this should be easy. Hey, it threads in. Now we want to just put these in place and not tighten them, because we're going to stick them on the boom and then tighten them. Okay. All right, this guy goes here. Loosen up. Don't be so inflexible. I might not be able to do that. All right, let's try it this way. I'll put that on first. Then we'll put this guy on top. Well, at least I'm pretty confident that it won't come off now. All right, 2 motors. We need 3, so here we go. Here's 3. 22 mils, let's go. Okay, it better fit. What the hell? Why is it doing that? Why is it doing that? Why is it doing that? Why is this one doing this? Oh shit. Okay, here we go. We gotta fix this motor. So it moves like that, but there's this collar on the end with the set screw. So I'm just gonna push it down and then tighten that set screw. Oh my gosh, that's so much better. So at least I know that this motor mount isn't trashed. The screws will actually go into it. Like so. Thank goodness. Look at that. That's so much better. Spinner. Where's the spinner? Right. So now we have motors. Oh my gosh, and it still folds. That's great. Now that we have our motors in place, let's put the stuff on that drives them. Here's our controller board, the KK2 Mini. This one's got some bent pins. Let's fix that right now. Shouldn't be too difficult. Just simply grab some of these metal things and move them. Yeah, this is gonna look... Alright, let's do them one at a time then.
So we definitely need the first 4 channels to work. The rest of them are for more rotors, and Tricopter only uses 4. Well, I mean, it uses 3 rotors and then one of these for the servo. I forget which way's ground. All right, one fits, 2 fits. Oh, the screen will come out now. That's nice. Just bend that back a bit. All right, 3 and 4. Okay, that will work for what we're doing. The screen is also jumping around, and I kind of don't like that so much. So, see some of this 2-sided VHB tape. You know what? I'll put it here. KK2 is fixed. Alright, so this guy got an arrow here that points forwards, and that goes there. Let's get a nice piece of tape. Square. I used to use earplugs. I would cut some earplugs and do 4 of them on the corners, and that would like do some shock absorption, but it turned out that that was a little too much movement. I hope this piece of foam tape is going to absorb the high frequency vibrations. It's always such a nightmare. There we go. Okay. All right, arrows forward. I want this right in the center of this little square here. Press it down. Okay, there's our brain. That's a good place to stop. Let's stop there.
Sit rep. It's been a couple of weeks. I've jumped ahead a bit. We're going to gloss over a couple things. What I've done is I've wired it and soldered it up. It's a little messy, but I had a problem. This one I had plugged in backwards. I reversed the polarity, plugged it in, and smoked one. This guy right here, I blew it up by plugging it in backwards, which evidently is a thing. I've got them wired in this manner, where I've got all 3 ESCs centrally located here, and they distribute power like so. The video transmitter has got a tap off of one of them, so there's pos neg, and that's going to give me signal. Let's give it a little try. Let's make sure I put this on. You're going to be attached to me for a moment. Let's make sure that this thing works. So let's just give it a quick test flight, shall we? It's a little bit gloomy. The wind's coming from that way. All right, first things first. Let's plug in here. This is always going to be fun to edit, isn't it? Well, that's not working. I'll just see if that works. On, it's on Tinkerbell. That's the model we're using. Power up. 4, that means, oh, yep, it's ready to go. And we have video signal. So, a little bit of wind compensation. Right, left. Let's do some yaw. And I'm hovering at about a half a stick. Oh, hell yeah. All right, well, this is a confined space, so I'm gonna just lift my hood, and holy shit, that's a lot of altitude. Stabilize, and I caught it. Disarm. We're disarmed. Okay. Success. Come on. Oh god, that's tough. Come on. Come on, come on, come on, come on. Gotta wiggle it. There we are. Alright, that goes off. That comes out. Thanks for watching. That was my video. So that was my video. A lot of things I would have done different. I had a lot of trouble with my microphone, or I didn't have my microphone, or it didn't work, or something like that. And it's taken me a long time to do this. I know this is like an hour long now, and the only people watching this are super fans and people who love me. So thank you. Thank you for watching this far, and I hope I've earned your subscription. I'm not sure if I'm going to do another video quite like this, because it's not it wasn't exactly perfect. So I mean, I'm learning. Let me know what you think. Let me know how I did. I mean, it's been so long that this tree now has a lot more foliage on it. Yeah, it's been real. So my next video is probably going to be something simpler, quick and easy. There is a lot of stuff that I would have done differently had I known. Hey, it turns out that my microphone records slower than the camera, so I have to adjust the microphone. I have to adjust my audio and play it at a factor of 1.00045 to make it sync up properly. I don't know if that's the camera or the microphone. Ultimately, doesn't really matter. At least I know how to fix it. But I learned a lot doing this. Hopefully you did too. Yeah, that'll do. That's fine.